Hello, good morning everyone, and welcome to this talk about apps on your wrist. And guess what? We're going to talk about smartwatches.
Cool.
So if you're not here to hear about smartwatches, then you're in the wrong room, just to make sure. Okay, before we start, we just wanted to know who you are. So in this room, normally we do that with hands raised, but I think it's Monday morning, so everybody needs to wake up a little bit. So if you have a smartwatch, can you please stand up? Woohoo!
Okay.
Okay. So obviously we're in the they are in the right room. Okay, I need my clicker. Who is an Android developer by standing up? Okay, not the same. That's already interesting. Who is an iOS developer? In a Java conference, that's a good achievement. Who is a Pebble developer? Okay.
Pebble.
So somebody even said, what? Okay, that's a good sign. Who is a Rolex developer? Okay, nobody. That's a good sign. And since we're going to talk about smartwatches, and I don't want there to be any confusion, who has already written a smartwatch app? Oh, 1, 2, 3. Great.
Yeah, pressure.
Who is a member of the Night's Watch? No, that's not the right talk, anyway. So just a few words about ourselves. My name is Sebastien. I've been a Java developer for about 10 years now, an iOS developer for 5 years. By the way, I wrote with a friend the first Devoxx schedule app 5 years ago. Okay, that's cool. It was my first project. I've developed app for the Pebble for 2 years. And I was actually the proud owner of one of the very first TikTok Lunatik. You're going to see what it is, and yeah, I was proud of it anyway. And right now, I'm VP of Engineering for Take It Easy, the fastest growing startup in Belgium. So, by the way, we are hiring. So, if you're looking for a job, feel free to come to me at the end. And that's it for me. Saïd?
Hi, I'm Saïd Eloudrhiri. It's quite complicated. So I started my career in 1992, and could you please, I'm mainly an agile coach and trainer, and sometimes I provide some help in the Devoxx for Kids. Who knows the Devoxx for Kids? Yeah, it's cool. So I'm providing some labs in Sphero, Mindstorms, and Code Combat. It's really fun. As an agile coach, I need to stay in touch with technology, so I create some side projects like Smartwatch or PixInc. And yes, I have to mention my kids, Nora, Ryan, and Jenna. And no, I have no kitten, but I have a dog. And as you can notice, English is not my mother tongue, so sorry for that.
Where is Brian?
In the kitchen.
Okay, so
is it okay? Yeah.
Level 1, check. So just a quick disclaimer before we dive into the real deal. We are not related to Google, Apple, or Pebble in any way.
No.
So this is just our return on experience. We've been programming on those little things for about 3 months now, and we just want to show you what we've discovered and how it's used. So all the materials used in this presentation are the property of their owners, and if you have any questions, then talk to our lawyer.
Yeah.
Okay, so before we do a little bit of code, at the beginning there was that, but can it really be called a smartwatch? Okay.
A long time ago.
Long time ago, so fast forward a few thousand years, and in the 70s you had that, not really a smartwatch per se, but it started to be digital, and at least it triggered the imagination of a generation. I think you saw it in a TV show. The Invisible Man or something, right?
Yeah.
Gemini.
Gemini Man, yeah.
This one really made me fantasize when I was in high school. A friend of ours had that, and he was doing some addition and subtraction from his wrist. Whoa, that was smart. Anyway, the first real experiments with a real operating system running on a watch. And that was, I think, actually a prototype by IBM or something.
Yeah.
And yeah, I talked about it earlier. I think this can seem like it doesn't make a lot of sense, but I think it's really relevant in that it really triggered the whole movement. It was a Kickstarter campaign back in 2011, and basically it was a way to wear the iPod Nano on your wrist as a watch. It was really dorky, but yeah, it worked, and the Kickstarter triggered so much interest that I think it woke up a lot of manufacturers, and I think it was pretty much at the origin of the Pebble project. Mm. And yes, in 2012, the first Pebble, very first generation, I have one right here. So it was the first real smartwatch, I'd say, of the modern era. The originality of the concept is that it uses an e-ink screen, so it can stay on for a long time, about a week of battery life, and it stays on all the time. And yes, there is an SDK to which you can develop apps, and there is even an app store and all that. So that was really the very first. And it was actually, back in the day, the biggest Kickstarter campaign ever. And actually, the second version of the Pebble remains the best Kickstarter campaign. I think these really triggered the interest of real manufacturers, I'd say, I mean mainstream manufacturers like Samsung. Mm-hmm. And in 2013, they announced the first Galaxy Gear, which was not an Android Wear, because Android Wear didn't exist back then. Yeah. But it was a full-on Android in a watch. So it was more like a phone that you wear on your wrist or something like that. And then, yes, Google noticed. And in 2014, they announced Android Wear. And one of the most popular watches was this one, the Moto 360. Which was round, so it made really people, okay, a watch is supposed to be round.
Not exactly round. Huh?
Yeah, there's this little black thing at the bottom.
It's almost round.
Damn it. Okay. And in 2015, I mean, it was announced in 2014, but it was really released in 2015, the Apple Watch. So the one that now everybody knows and that we're going to show you today. So that was just for the history of smartwatches, very quick. So now the question, of course, is why develop for smartwatches beyond all the images that we have in our memory from Star Trek, Michael Knight, and James Bond.
James Bond, yeah.
Beyond all that, I think a lot of people see it as a gadget. Of course, it's a new platform and so on, but our goal is to show you that it's much more than that. A few key characteristics and a few key interesting things about the platform. The first one is that the glanceable aspect. So what we mean by glanceable is that it's not like a phone app that you're going to interact with for a few minutes, or sometimes even get lost in it, like you're in the subway and you're looking at your phone for minutes and minutes. Here, every interaction is supposed to be a few seconds long. So you have to be very creative in the way you do your UX. You have to be very precise, very succinct. Yeah. Anyway, accurate.
It's correct.
Just the information. Yeah, it's correct. You validate. So yeah, you have to be very efficient in the way you communicate information, and it has all sorts of impact on not only on the design but also on the APIs themselves. It's full of sensors. That's really interesting. Of course, your phone already has some sensors like a GPS, accelerometer, and all that. But here, the sensors are actually on you all the time. So there's a full load of data that you can use and that you can aggregate. You can combine it with the data coming from your phone and so on. So it's really interesting that way. And so, for example, there are, accelerometer, of course, Bluetooth and Wi-Fi in some watches. Not all watches have Wi-Fi, but some watches even have a barometer. You have the heart rate monitor, which is kind of cool. Some watches have the GPS. You have microphone. I mean, a whole lot of them. That's probably one of the most interesting things. On a phone, in terms of user experience, on a phone, you usually take out your phone and you do something with it because you want to do something with it. I want to find my way in the subway. I want to launch a search on Google. I want to check my latest email. Of course, there are notifications as well, but that's not the only way to use your phone. On a watch, a lot of things are really triggered by notifications. So pretty much everything you do is in response to a notification. You can also launch traditional apps, as we'll see, but most of the interactions are done through notifications, as reactions to notifications. So here, for example, you receive a message, you want to see it in detail, you want to reply directly, I mean, there are plenty of use cases like that. Something that might seem as a constraint, yes, it's a small screen, so it's constrained that way, but it forces you to be creative, and once again, to think about how you display information, and also how people are going to interact with it. Because even though most smartwatches have a touch screen, if you start interacting with your finger on the touch screen, then you won't see anything anymore. So you need to think twice about how you display things. And in terms of interactions, it's not just the screen that is smaller, but all the user interaction, all the user input and outputs are completely different. You don't have a mouse and keyboard, of course. Even the touchscreen is not that easy to use. You have a vibration engine that can be very powerful, especially in the Apple Watch. You have a microphone, you have the smart wheel on the side for the Apple Watch, you have buttons and so on. So it changes the way that people basically give orders to their machines, so to speak. And like a handkerchief, like a toothbrush, like the thing in Inception, it's not something that you let others do, or others use. So there's a whole lot of things that you can do knowing that it's only the main user of the watch that's going to use it, and nobody else will see it. So in terms of security and so on, it has plenty of implications. So what we're going to talk to you about today, so there's a lot of platforms out there. The most recent one is probably the Tizen platform from Samsung. It has its own SDK, its own APIs, of course its own watches, that's the goal for them. But it's very marginal right now. You have the Pebble, which has grown quite a lot in the past few years, and actually I read an article the other day that said that actually the Apple Watch didn't do any harm to Pebble at all. They doubled their sales since the Apple Watch came out, so it's growing fast, even though it's still a pretty geeky audience, I'd say. And the two main contenders are definitely Android Wear and Apple Watch, and we're going to focus our attention on that today. We're going to speak a little bit about Pebble at the end, but since there aren't really a lot of Pebblers in the room, but I'll show you why it was challenging to mention that. So let's start a little bit with the design constraints before we dive into code. For the Apple Watch, it's pretty simple. You have only two form factors, the 38mm and the 42mm. It's all square, so you don't have to think about different ways to show information and so on. The resolution is very close, and all the APIs take into account the difference in resolution, so auto layout and all that sort of stuff. So it's really easy that way. Not a lot of form factor fragmentation, I would say. There are mostly four kinds of applications that you can develop. Of course, full-on apps that you can launch from the launch screen and interact with for a long time. You can also do notifications, so you can customize the way notifications are displayed. For example, there's a health app that can send your health data to your doctor, and when your doctor receives a notification, he can actually see all the health data directly in the notification. There are glances. So glances is a special concept. It's like a watch face, but directly accessible from the watch. So no, I won't be able to show you that way, but I'll show you later how it works. And complications, yeah, it's a little counterintuitive the way it's called, but it comes from those little things that appear on real watches, on Rolexes and so on, that complicate the mechanism. But here it's just small widgets that appear on your watch face, so you can have information synchronized between different widgets. And that can be pretty powerful, especially with something that they added now, which is called time travel, and you can actually, with the click wheel, you can simulate another time and see all the widgets update accordingly. It's really nice. In terms of design guidelines, of course, Apple is really adamant to give some guidelines about all that. Personal communication is one of them, so for them it's really a communication device. I'm not really convinced, because all these things where you can draw on your watch or send your heart rate to somebody, I'm not really into that, but yeah, for them it's really about personal communication. Holistic design means that you should take into account the entirety of the device and all the user interaction capabilities that you have. And lightweight interaction, because once again, only count on users using your apps for 2 or 3 seconds at a time. For Android Wear, Said?
Yeah, you will see that for Android Wear, it's quite different. We have different form factors, different kind of application, different, well, we have some similar guidelines for the design, but welcome to the fragmentation with Android. You know that we have different kind of mobile phones, and it's the same for the watches. We have square watches, round, almost round, different kind of resolution, etc. And it's really challenging when you develop an application, because you have to support all these watches.
Beware for the triangle watch. Someday they'll do it. Prepare yourself.
So as I said, you have the square one, the round, and the almost round. It's called round chin. This is the form factor promoted by Motorola. Anyway, Motorola is the only one using this kind of design. The reason is that Motorola is putting some sensor at the bottom of the watch. Regarding the UX principles, the main one is the context stream. So the context streams allows you to display some cards and to browse those cards in a vertical or horizontal way. These cards will be used to provide you in a timely manner the information that you are required or expected. The cue cards, if you are not able to find the information, you can say, OK, Google, and try to find the information, or to tap on a specific icon. Contextually aware and smart, this means that you can create application and you can use your sensors to allow you to receive information regarding, for example, your location. If you are in a store, you can receive some discounts, etc., and to interact with your application. This is the design of a card. It's quite simple. You have a background image, an icon, and you have the title and a short description. So here, we are really in the glance way to create application. You have to find quickly your information without clicking a lot of things.
And by the way, this Alice Young, if you start developing for Android Wear, you will get to know her very much.
She's really annoying.
I don't know who she is, but she appears all the time on the device.
Exactly. In terms of notification, you have several kinds of notification. The one that is natively supported by your watch is the bridge notification. It means that if you receive a notification on your phone, it will be redirected to your watch. But of course, you can create custom notification. You can create your own one, as we do for a smartwatch, with a page. You swap your page, and you can reveal some actions button or additional information. And of course, you can create a full screen app, as we do for smartwatch. But a smartwatch is a watch, so you can create watch faces. This one, it seems quite complicated, but you can see that there are a lot of features. So next step is smartwatch. This is an application that we have created for this talk, for this session. It's available on smartwatch.com. Did you already install the application? No? Yes?
So if you have a smartwatch, either Android Wear or Apple Watch, you can find links to install it if you want. We're going to show you the code anyway. And by the way, now you understand why our hashtag is smartwatch, because that's the name of the application. So just wanted to show you what the app will look like, so what we are heading towards. Of course, the Apple Watch on the left, the Android Wear on the right. So of course, you can browse the schedule, so that's the list of the days. For each day, you can see a list of talks, and tracks are color-coded. You can see the title and the room. And if you tap a specific talk, you can see the details. with the summary and so on. And this little star is to add it to your favorites. So just a word of warning, this is not using the official API for the favorites because we discovered it late. So we had to implement our own favorite feature, but still it works. And yeah, on the Android Wear Watch, we're going to show you how to switch from pages and so on. And yeah, you can have details about the speakers. There's even Twitter integration on the Android Wear, and that's it.
So we have a bonus on Android Wear. You can open Twitter on your phone.
Yeah. So now we're going to show you. So the goal is to show you different elements and different interesting things that we can do with smartwatches. So we're going to dive right into code and show you how the environment works and so on. So Saeed, show us what you got.
Yeah.
Let's switch screen.
Hold on, because I have
you have some slides, sorry.
So when you have to create an application for Android Wear, there are a lot of prerequisites. For example, you have to check the requirements. You need to ensure that your phone is compatible with your watch, that your phone is able to install and use Android Wear. You have to install Android Studio, so it's a Java conference. I'm sure that you know how to do that. You have to choose to select to install the appropriate SDK library for Android. And then you are ready to create your project. It will be a project containing mobile and Wear modules. If you want to test your application and you don't have any real devices, you can create Wear emulators. And of course, we recommend to create an emulator per form factor, round, square, and round chin. And for our Hello Devoxx, we will just change our resources to tweak the string and to run the application and to see if it's working. Regarding the requirements, yes, you need a phone with Android 4.3 or higher, and the watch Android 5.0. You have a link. You can open this link from your mobile phone just to ensure that it can be used for Android Wear. Android Studio, blah, blah, OK. And yes, this is important. This is the list of libraries that you have to use. So we'll switch to...
Okay, we are crazy that way. We do live coding.
Yeah, live coding.
And that's the moment where can you please stop downloading things from BitTorrent or anything, because we need the network. Well, not right away.
So I will create a new project, whatever the name, demo01. Choose a folder.
Where's your desktop?
Yeah, it's okay. Next. So here, I'm going to select the minimum SDK for my phone, so that's okay. And I will select the Wear module. I will keep this one, okay. So you can see that you can develop for Android TV, etc. Or also to manage your car. A blank activity, that's okay. Default name, okay. Here I will choose the blank Wear activity. The other one, always on Wear activity, is a new feature provided with Android Wear 5.1, I mean. And it allows your application to be always on your watch. But I will just keep the simple.
But by the way, for those who are not Android developers in the room, the activity is the equivalent of a screen, right?
Yes, the activity will use to inflate your layout to display your views.
Okay, so it's a controller for a screen.
Okay. So I have here my demo application. Mm-hmm. So here, by default, on your preview, you have a phone, but you can choose, you can select the appropriate view for your watch. I will take here a square, okay. So what we have
can you
here,
zoom in on the code? A little?
Sorry?
Can you zoom in on the code?
Yeah.
I mean, make the code bigger so it's readable. And not just show, yeah, that's it. Perfect.
Okay. So here you can see that you have two modules, module and wear, and how is it possible? On the build Gradle for the mobile, we are importing the project wear. This is why we will be able to build the application and also the wear module. We will start by have a look on the layout. So here, this is the main layout, the layout that will be used by our activity. And we can see that we have a special type of view. This view is provided by the wearable library. It's called Watch View Stub. And this layout is able to link a view depending the form factor that you have. Rect, it means square or round layout. This means that you are able to create an application that will look different on a square watch or round watch. If I take here the square one or rect one, we will see that here we are using a string, a resource string. So I open the string, I would say hello, Devoxx. And I have a specific string for the square one, Devoxx. I would say here, round. That's it. I have an activity here that will just inflate the view and then to use the string, but we are not doing anything with the text view. So I'm ready to run the application.
So all of that was generated by the project wizard?
Yeah, exactly.
Nothing fancy.
Suspense. So here I have an emulator already opened.
Okay, that's the moment where we need the elevator music.
Yeah. So here I will choose my emulator there. Come on. Suspense.
There it goes, the log appears. Okay.
And voila. I'm sure that you are impressed by that. Yeah. Don't be shy. Yeah, okay, thank you very much. 2 beers there.
But okay. I'm not.
So believe me, I will not spend my time showing you that it's also working on the round form factor, but it works.
Trust his word.
Yeah.
Okay, so that's what you can do on Android then.
Yeah.
Let me show you how it works on iOS. So, first things first, let's kill that for now. Let's launch. Before we actually dive into the code, I have a few slides myself, so let's do that first. Okay, so that we showed you. Yeah. We copied all the code and stuff in the slides, so that it's easier to reuse afterwards. So, for iOS, the first thing to know is, of course, we don't have Android Studio. There is kind of an equivalent. I mean, JetBrains is all over the place now, so they do something called app code, which is supposed to be a replacement for Xcode, but there are some missing parts yet, and especially they don't have Apple Watch support yet. They just added Swift 2 support, so that's already good. So you have to use at least Xcode 7. You can use any of those 2 languages, so either Swift or Objective-C. I strongly advise against using Objective-C to start new projects now. It is still supported, but it won't be for long, I think. I think pretty much half of the SDK team at Apple is working on rewriting everything in Swift, so it's going to be big. you have two main things to know about WatchKit and WatchOS. So the first version of the SDK was WatchKit 1, and it was so that you had to have your phone with the watch because the watch couldn't do anything by itself. It needed the phone to connect to the network, it needed the phone for pretty much anything, and the app on the watch was really dumb. Now in WatchOS 2, a lot of things run actually on the watch, but you still have some WatchKit parts that are really important. You can either create an iOS and WatchKit project from scratch, if you know that your app is going to have a watch extension, or you can also add a watch extension to an existing iOS project if you already have some iOS app that you've been working on. There's no way to write a standalone watch app. On Android Wear, you can actually have an Android Wear app with a hidden Android app. So you don't see anything on the phone. But
yeah, you can hide the companion application. Companion application is the application that you install on your phone.
Okay, but for iOS, you do have to have a companion app. And you have the iOS and WatchOS simulator. I'm going to show you that right now. So let's switch now to the demo. So the first thing I have to do, of course, too many watches on this table, is to launch Xcode. So for those who have never seen Xcode yet, prepare to be amazed. Okay, this is the full code. Yeah. Anyway, so let's create a new project. Okay, let's use that. New project. There we go. And you see, you can either, here you can create an iPhone app with a WatchKit app. We're going to do that. Call it Hello Devoxx, how original of us. Oops. Okay. And I'm going to check all the boxes here. So this is to prepare things that you might need if you want to do a custom notification, a glance, and a complication in addition to your main app. And we're not going to do them here, but it always gives you good conscience to check those unit test boxes. Anyway, so we choose a directory. Let's put it right on the desktop. Of course, I don't have any room. And that's it. So if I go full screen, I don't even know if I can zoom in here, but yeah, I can do this like that. Yeah. So the interesting things is that you have several modules in the project. You have the main app, that's the Hello Devoxx here. You have the WatchKit app and the WatchKit extension. So your watch app is basically divided into two parts. The WatchKit app is what runs solely on the watch. And the WatchKit extension used to run on the phone, and now it runs on the watch itself. I'm not sure why they kept those separated now, since everything is running on the watch. But I'm sure they have good reasons, because, come on, it's Apple. You have settings for all the modules. I won't go into details about that yet. Mm-hmm. The interesting thing is that you can design your entire app with just the visual designer, so the interface builder, and then connect it to your code. And that's what I'm going to show you now. So if I open those two modules, so in the WatchKit app, I have the storyboard, and the storyboard is the visual designer of Xcode. So you can see the initial screens that are generated, and then we will be able to see the whole flow of the app and so on. And of course, do all the layouts in here.
And the layout editor is designed specifically for the watch?
Yeah, in this case, it's just for the watch.
It's not the case for Android Studio.
And you can also customize your glance and your notifications, but I'm going to show you that later. And so here we already have a first interface controller, so that's the equivalent, I guess, of an activity on Android. And yeah, the interface controller has a view part and a controller part, and we'll have the controller part in the WatchKit extension. So that's the interface controller here. Yeah, the code is readable like that. So it's an instance of the WK interface controller, so that's important because on Android, from what I've seen, the components are pretty much the same on Android Wear than on the Android phone, except for a few extensions. But on iOS, everything is specific. So all the UI components that you are used to use if you do iPhone development or iPad, here you can forget about them because it's all different. It makes sense because it's very specific and the user interactions are completely different, but it explains partly why it took Apple so long to release its SDK. So here, we're not going to do anything in here for now. I'm just going to go back to the storyboard. And here I have a palette of components. I'm just going to drag and drop a label, center it horizontally and vertically. Okay, I forgot. Oops. And here I'm going to set it to hello, Devoxx. How impressive and original. Okay, and then all I have to do is to choose here the WatchKit app as a run configuration, and by default it created 2 emulators, so everything runs on the laptop. You'll see why it's important later. Here it created an iPhone 6s with an Apple Watch 38mm, an iPhone 6s Plus with a 42mm watch, and you can create as many emulators as you want, so usually I prefer to work with an iPhone 6 and a watch in 42mm. I'm just going to select this one, and I hit run, and you pray. Okay, so now the phone emulator has just launched. That's this little part here. Of course, we can't see anything. And the watch emulator has just launched here. Okay, and it's going to work for the first time. Perfect.
Wow.
And voila. I'm proud of myself. Okay, I can go now. No. I still have some things to show.
I love your spinner.
Yeah, the spinner is really nice. And sometimes it displays longer than I expected, but okay.
So by the way, I'm discovering most part of the Apple Watch application.
Don't say that. It will look like we haven't prepared. Okay, so yeah, that's how you do it on the Apple Watch. Let me go back to the slides. So I showed you creating a project, and step 1 is done.
Cool.
So what do you have in store for the next part? Ah, yeah, you're right, sorry.
Yeah, we have to talk about
the API first. So Smartwatch, as you've seen, is an app for browsing the schedule for Devoxx. So quite naturally, we use the CFP API for Devoxx, with which you can have access to a list of schedules. In each schedule, there are slots, and those slots can either be break slots or talk slots.
Yep.
So that's the general model. And each talk slot can have speakers with more details, a bio and an avatar and stuff like that. That's how the API works. In terms of code, this is what it looks like. This is, for example, the endpoint for loading schedules. You have a list of links, and each link has a title, that's just the day, and a very practical href that gives you the URL to the next step in the loading process. So, and if I load, for example, the schedule /Monday path, this is what I get. I get a list of slots mixed in with break slots and talk slots, so there's no sorting here. But you can differentiate between talk slots and break slots just by looking at the break field in a JSON. If it's empty, then it means that it's a talk slot. If there is something in there, it means it's a break slot, and vice versa for the talk part. Anyway, so of course you have several, I mean, it's the same API for all the Devoxx events. So this app that we're showing you today for Devoxx Belgium should work flawlessly.
I already tested for France.
For
France. We just have to change the URL and it will work.
Okay, so we might add a switcher at some point where you can actually browse all the conferences. But so yeah, it works for Belgium, for France, London, Morocco, and Poland as well. So yeah, we just wanted to show you what the API looks like before diving into the implementation that's going to read and consume it. So the first step will be to just log the schedules on the console. Let's start simple.
So this part will be a more complicated than the simple hello world. We are going to fetch the schedules from the REST API server and to log these schedules on the console. So to do that, we are going to play with the Google Play services and with a concept that is called the Data Layer API. This is a set of API that will allow you to allow your watch to communicate with the phone and vice versa. It's really a concept that you have to understood in order to create your own application. For the step 3, we will use two sets of API, the Node API and the Message API. And the script will be the following. The watch will send a request to the phone. The phone will parse your request and will say, hey, guy, you want to get your schedules? OK. I fetch them, and I will display them on the console. So the main concept is to use the Google Play services. And you know Google Play services is a set of services and libraries, Google Map, Google Fit, etc. But you have also a wearable part, and the wearable part cover all the communication channel API that you can use for that. So in order to use the Google Play services, your application has to connect to the Google Play services by using a Google API client. And yes, that's it. For the Node API, what is doing the Node API? Well, it's doing, in brief, is able to get information about your local node. Your local node is your local device, or all the connected nodes in the Android Wear network, your Android Wear network. It can display the name, the ID, the unique ID that will be used when you will try to exchange a message between your nodes. And also you can get an information to know if the node is nearby your local node. So
just about the nodes, it means that in Android Wear, the watch is considered just like another Android Wear node, and it's not specifically a watch.
Exactly.
That's
and we can see here that, you know, for Google, the notion of Android Wear is really beyond the watches. Google is really thinking about the Internet of Things. And we can expect that in a few months, Wear will be compatible with a set of devices.
With T-shirts and...
Yeah, exactly.
That's
beer or whatever.
And and of course the Google glasses, sorry.
Yeah, Google
it's
glasses.
Irrelevant now.
The version 3.5. The other set of APIs is called the Message API. So it's a simple API that allows you to send a message. It's a one-way communication. And the message that you have to send to your node, remote node, is called a data item. Data item is just a set of information composed by a data path and a payload. That the payload is optional. But the payload for this kind of data item is really specific for small messages, small message payload. Here, this is an illustration of what we have. For example, we can have /schedules. This is what we will use. So when the phone will receive a data item beginning with /schedules, he knows that this information is dedicated for the schedules. The payload is limited to 100 kilobytes. If you want to watch a Titanic movie on your watch, so you will have to use the notion of asset. Is a specific data item. It's a binary blob. And this asset will be used by another set of API that we will see in the next steps, called the Data API. And the Data API will manage the stream of this asset automatically for you. Because,
admit it, that's all you want to do with a smartwatch, right? Watch Titanic.
Yeah, 4 hours like that. He will finish at the hospital. So this is just a small description about what kind of method we will use. So from the watch, we will prepare the data item, call the Message API, call the method send message. Everything will be sent on through the data layer. The remote node here, our phone will receive the data item. Specific method will be automatically called by the listener. It's called onMessageReceived. He will parse your data item. It will use getPath and getData, and with the getPath, he will receive your path /schedule. It will say, okay, I will have to do something. And you say, you see, when we are talking about communication channel, of course, your watch is able to communicate using Bluetooth, but also Wi-Fi. This is a new feature provided with Android Wear 5.1.1. But on an Android Wear device, the Wi-Fi is only used to find your phone if the two nodes are outside the scope of the Bluetooth. Don't try to reach a remote server with your Android Wear using Wi-Fi. It will not work.
So it only works if your phone is out of reach, but if it wants to go to the internet, it has to go through the phone.
Yeah, exactly.
Okay.
So we'll create the Google API client, connect and disconnect from Google Play services. We will add a button listener. And for the phone part, we will use a wearable listener service. So it's a specific service that is used to receive events coming from the data layer. We will process the schedules, and we can switch to the demo. It's better than 100 slides. So here I have my project, and we can review what it's able to do. So from the watch, you will see here that we use Play Services wearable, but it's automatically injected by Android Studio when you create your application. By default, is set. And this dependency, of course, it's used. It allows you to use specific features of wearable. From the watch, the mobile, we have also defined the Play Services. It's automatically injected by Android Studio. What has been changed from our activity? So here we are on the watch, the Wear module. We have used overridden two methods, onStart and onStop. And these methods are used to work with the Google API client. onStart, we will connect to the Google Play services. onStop, we disconnect from Google Play services. And we have a method here, hold on, there, okay. And we use the Node API to have an information about our nodes connected to the Android Wear network. And we will here broadcast the message to all connected nodes. What are we going to send? A path and our message payload. And the path is schedule path here. Oops. It's just a static string.
Okay, so that's just to identify the message from
yeah,
the
exactly.
part. And so what I see is that even though there is a unique pairing between the phone and the watch, so a watch can only be paired to one single phone, right?
Yeah.
Here you still have to browse all the available nodes,
yeah,
and broadcast your message to all the nodes.
Yeah.
Okay.
So it's a way to do that. I'm sure that there are other ways. So here, with this method, we have the data path, the message, but for this step, the message payload is optional. We are not going to use it. And we send this message through the data layer by using the message API.
And you do that it's asynchronous. You do that in the background with a thread thing. And
this is something that is important here. When you connect to the Google Play services, we use add API wearable.api. What it is, Google Play services contain a lot of services and library. Here, we just say that we connect to Google Play services, but we are only interested to the wearable API. That's it. And from the phone here, we have created a service there called Wear Service. If I switch to the manifest, this is where we declare our activities, our service, our listeners. You will see that we have we have mapped our Wear service with a specific filter. All events coming from the data layer communication channel will start this specific service, Wear service. And what we have here, you see Wear service. It extends wearable listener service, and you have a method on message received that will be called each time you receive a message. And the process is quite simple. You receive it, you have a message event, and you will retrieve, the path and the payload. I just compare if the path is equal to scheduled path. Yes, okay. So I'm going to retrieve the schedules from Devoxx. And what I'm going to use here is a REST API client. I'm not going to describe the REST API client, but you just have to know that I'm using a retrofit. It's a REST API client library provided by Square, and it's quite easy to use. You just have to declare your endpoint here. It will be used by retrofit. I declare my endpoint, get schedules with the URL, and well, I will just pass a parameter to say I'm interested in this conference. So here, to retrieve the schedules, I invoke my endpoint. I send the conference name. Conference name, what it is? Hold on. It's there. It's just a resource. So I have defined here in my string resources the URL of the Devoxx.be API and the conference name. So you can change this to fetch the schedules from Morocco, from Poland, from UK, or better, it's to create a visible companion app, just to say, I'm interested in the conference from UK, for example.
And by the way, just a question: the Wear service here, it runs in the background on the phone. You don't need the companion app to be running when the watch sends the message. It's just woken up by the.
No, when you are using the message API, the remote node needs to be up.
Ah, okay.
Yeah. If you want to send a message without requesting that your node is up, you have to use the data API.
Okay, so that's an interesting part to know about.
So here we retrieve the schedules. We have a callback here. We will map the JSON response to a class called schedules, and then we are ready to log the information. So now it's time to pray.
Ladies and gentlemen.
And to test the application. So here I'm using a real phone device.
So you cannot have a simulator, I mean
a bundle
software.
of, no, unfortunately no.
So that's a good thing to know. If you want to run an app in the watch simulator, you have to go through a physical phone. Okay.
So I deploy my application on my device. It's time for a dance if you want.
Yeah. just for the picture. Okay. It's a trap.
I prepare here my emulator. Yes, it's slow.
Yeah, and here, so it's compiling the code, packaging it, sending it to the phone, running on the on the phone. And yeah, by the way, what he didn't show you here is that in order for the phone to communicate with the emulator, I mean for the physical phone to communicate with the emulator on the laptop, he had to do some special voodoo magic to redirect ports and do all sorts of weird things with ADB command line. So it's a pretty geeky stuff to do, but he already did that before. So, but all that is explained in the slides afterwards. So if you want to do that at home.
I choose my Android device. Okay, this one. So Android Studio is deploying the APK. Do you want to uninstall the application? Yes. Don't worry, don't panic. It's normal.
Everything is under control. So now it's running on the phone.
So the app has been installed, but the app on the phone is just an activity with just a hello world message. Now we are going to deploy the APK, the bundle to the watch on my emulator.
The Gradle build is running. It's good to know. A little bit of voodoo magic? No.
Yeah. So here, if you want to allow your real device to communicate with your emulator, you have to use ADB. This is a command that will allow you to have a look on your devices.
And here you can see your
so here I have
066,
etc. This is my Nexus 5, and I have my emulator. So to link the physical device to my emulator, I have to run a command. Here it's stored on the script. If I...
Okay, that's not a complex thing.
It's a kind of port forwarding. This will allow Android Studio to link your devices. Without that, we'll not be able, the emulator will not see the phone and vice versa. So where are we here? No?
That's the mobile part, and the emulator part is still starting.
Yeah.
Well, nothing seems to be happening anyway, so go ahead. Oh, okay.
Oh, yeah, okay. I missed the window. Okay. Here, yes, I have make a change here on the layout. I have just add a button. So here I'm going to use my square. You know, nothing magical, just a button. His name is Get Schedules. And on my activity, I have add a listener here on the Get Schedules button. Set on click listener. When you tap on your button, we will call send message. Send message is the method that we have seen, the principle there.
Okay.
Okay. So suspense. I will check my console. Switch to my watch here.
Your phone.
Yeah, on my phone. Get schedules. And
boom.
Ooh, yes.
Okay, so that's a very, once again, it's a very geeky output.
Monday, Tuesday, Wednesday, Thursday, Friday. So here, Get Schedules has sent a message to the phone. The phone has performed a REST API call to the Devoxx website. It retrieves the list of schedules. It maps the JSON response to my data model, and then displays the list of schedules on the console.
Okay, so here you're showing that you're logging the schedules from the phone itself.
Yeah.
If you wanted to log it from the watch, you would have to send a message the other way with the data and so on.
It will be the next part. Please don't spoil the
sorry for
the
the
talk.
spoiler alert. Okay.
Great.
Okay. That's nice. How can I compete with that?
Challenging, yeah?
So, yeah, we've shown you all that. So once again, the detail of the code is in the slide, so you will be able to go through it again. And, yeah, all the details. And the step 3 was done. So let me show you what we can do with iOS then. An interesting part is, as you've seen here, the network connection has to go through the phone, and you need to set up some special communication between the watch and the phone. On iOS, there's something nice. The default, I haven't used any special library for network access. Of course, there are equivalents of retrofit and all that. I don't remember the name now. They changed it anyway. And you can use those libraries. Here I just used NSURL session, which is the default pretty low-level API to access the network. And the good thing is that you can also use it directly on the watch. And the principle is that if the phone is connected and it has a good connection, then the watch will actually forward the calls to the phone. The phone will perform everything, and the data will be sent back to the watch. If the phone is out of reach or it has a bad connection, then the watch will connect to the network itself and do the same thing. So you don't need to do anything special. It's completely transparent for the developer. You can just use NSURL session from the watch and enjoy the modern age of smart APIs, whatever. I'm going to show you how to do that now. Notes so that I don't forget any important step. The first thing that we need to do, I'm actually going to use the same project as before. In the latest version of the SDK, Apple has done something that might be a little troubling, but the NSURL session network, API, can only access HTTPS APIs by default. So they're planning ahead for the switch to full HTTPS web in a couple of years. And of course, you can disable that setting, but if you forget to do it, then it will say, yeah, I can do that, because you're trying to access an HTTP API. So that's a small trick, just not to forget, otherwise we'll get some exceptions. And there we have to go in the settings for the module. Everything is not very readable, but so this is just a settings file in Xcode. It's a dictionary. It's a hash map, basically. And it can be a hash map of hash maps. I just need to add an entry and call it app transport security settings. That's auto-completed. That's nice. And in that dictionary, I can add several keys. I can either allow arbitrary loads. It's not very visible here. Okay. I can either allow arbitrary loads, or I can configure by domain what I want to do and allow or not. So here I trust that the CFP Devoxx API is trustable. And I just go allow arbitrary loads, set it to yes, and I'm going to be good to go. That's the first thing that is important. The second, for everything related to the network, we're going to create a special singleton to have all the API calls in the same class. So here I'm creating a new file, WatchKit class, call it Devoxx. It's just a NS object, so that's the equivalent of the object class in Java. And of course, I'm going to use Swift. By the way, you can, in the same project, you can combine Objective-C code with Swift code. So if you have an existing iOS app, written in Objective-C, and you want to write an iOS watch extension in Swift, you can. There's no problem with that. There are bridges all over the place, and so it's pretty nice. So where will I create that? Yeah, default directory is okay. So this is the simplest class that you can have. Here we'll just create a shared instance because it's a singleton. So static var shared instance equals
Live coding.
Devoxx, yeah.
You are insane.
Yeah, I know. That's what my mama says. Okay, and yeah, that's it. That's how you call a constructor in Swift, for those who have never seen Swift code before. And that's all we do. Now, okay, let's already have a method to load schedules. Okay, for conference. So yeah, when you do live coding in Swift or Objective-C, it's kind of big because Apple really encourages you to use big names and very verbose syntax for your identifiers. So here, our method will just take the identifier for the conference so that we can switch to another conference if we want. And it will have a callback because it will be asynchronous and we don't want to wait for the network to come back with actual data. And the way we declare those closures in Swift is still a little weird, but it works that way. There's dictionary to void. Okay, there we go. So NS dictionary in the iOS API is the equivalent of hash map. Basically, it's just a dictionary of data. Now there's the NS dictionary that comes from the old days of Objective-C, and there's the native dictionary. And they are, how do they call that, toll-free bridgeable, so you can basically switch from one to the other. I'm just using this one because it has some neat things I want to use. So the first thing is I need to create a session to access the network, pretty much like Said did for the REST API client. But there is a bug. I filed a bug report for that to Apple, so I'm still waiting for an answer. But it's a very weird bug because basically, by default, the request cache is enabled. And when you leave it enabled, it loads all the JSONs twice. So in the response from the network, you have the JSON and then the JSON again. So it cannot parse, of course, because it's not valid JSON. Anyway, so in order to avoid that, I'll just do configuration NS URL session configuration default. So I'm creating a default session configuration, and I'm just disabling request cache policy, NS URL session cache. No, that's not the one. Let's request cache policy, reload ignoring cache. And now that we have created our configuration, we can create our session, NS URL session. So once again, I know this is a Java conference, so I'm hoping that some of you don't feel dirty when you leave the room.
Some people
don't worry.
Are sleeping.
So configuration, yeah. So now we have our session. By the way, in Swift, if you declare a variable with let, it's a constant. Here we don't need to change it, so that's good. Yeah. If you declare it with var, it's a variable. So that's just something to know. In Swift, you also have an interesting concept, which is called optionals. Optionals are basically a way to say this variable can be null or not. And if it cannot be null, then you have type safe all over the place. And that's really neat to use. So what we're going to do first is create a URL. Schedules URL equals, oops, sorry, there's one too much equals. And this URL with a string. And this is going to be HTTP CFP Devoxx.b/API/ I think that's it. No, /conferences. / and I can do some string injection in there. So I'll just use my conference parameter, and that's it. No, I need to add the schedules path behind it because I know I want to load the schedules. So what's interesting in there is that the NS URL constructor can fail, because if this is not a valid URL, then of course it will fail and return nil in this case. So I need to explicitly say, okay, I know this URL is valid, so I put a a hash bank to say, okay, this is really not null, I'm sure of it, so that I can use it directly without doing some tricks afterwards. Then I can create a task with the session, data task with URL. I can just use the URL I've just created, and it has a callback that returns some data, a response, and potentially an error. And that's it. So what we want to do with that, I'll show you later, because there's something that we should not forget. When we create a task, it's not run by default. So if you forget this, you might have to wait for a few millennials before your app does anything. So that's also important to remember. And now that we have that, we can actually do something with the data. So the first thing we need to check, here you can see the data is NSData question mark. It means that it's optional, so it's nullable basically. If I don't check that it's not null before using it, and then I'm screwed. So, and the compiler just doesn't want me to do that. So that's quite neat of him, but that means that I have to do something special. I'm using the guard instruction here, and I just say data equals data where data dot length. So here I'm just checking that the data that I receive is there, it's not null, and it has a length over 0 so that I know there is some content in there. And if not, then I just print no data. No, actually I just print the error because I would probably have an error. And I return because I don't want to do anything else. So at this point, beyond the guard sequence, I know that I have some data, and I can actually return it. So before I return it, I need, of course, to parse it, because it's pure data, and I need to parse the JSON in it. So let schedules dict equals NSJSON serialization, JSON object with data. I can give it the data, and in terms of configuration, I just say allow fragments. That's just to make the JSON parser a little bit more easy to use. Let's say less strict. Now, if I do that, you see that I have an error, and that is because, of course, if I don't have proper JSON in the data, then the parsing will fail. And this time, if it fails, it throws an exception. That's a new feature in Swift 2, by the way. Before that, you still had to use the old NS error kind of thing, like you can still see here. That's a remainder of the past. And now you can actually throw exception, catch them, process them properly. So here, if I don't process the exception, then I'm not gonna, I mean, the compiler will complain. So in order to process an exception, it's a little special for you Java developers in the room. I have actually to put the try just before the instruction itself, and I have to do everything in a do catch block. That's it for now. I don't need to catch a specific exception. I'll just copy that over there. And now it doesn't complain, and I can just print the error. The error is actually not visible here, but it's free. It's free in this context of the catch. So now it's still complaining, yeah, because I'm initializing a variable that I'm not using. So just give me a minute. Come on, we're going to do that. And yes, now we have parsed the data. We need to do something with it. So let schedules array. So if you remember in the API, the response has a links field that contains the list of schedules. So we need to go to that. And the way we do this, if I remember correctly, yes, schedules dict, and we just need the links part. And we know that it's going to be an NS dictionary or not. That's why I use the as question mark thing. Actually, no, it's going to be a list of an array of NS dictionary. My bad. Okay. And here it still complains because, yeah, I'm not using the schedules array. Okay. And yeah, that's pretty much what I wanted to do. Now I have a list of dictionary of NS dictionaries that I can return to my callback. Except this one, actually the schedules array is an optional list of NS dictionary. So it can be null, and I want to make sure it's not. So in order to do that, I just do if let. Okay, and then I call back with the schedules array. Yay, no more warnings. Of course, if it's not, then I need to print an error, throw an exception. You get the gist. We never cannot find links. Okay. And that's it. That's the code that calls the API from the phone. Now, of course, we haven't called this method anywhere. So I'm going to go to the extension delegate. So in the watch app, that's the equivalent of the app delegate. It's basically what the class that manages the whole life cycle of the app. Mm-hmm. So here there's a method when it has finished launching, when it became active, and so on. So we're actually going to do it in the did become active. So every time we launch the app, it's going to go to the network and fetch the schedules. So here I'm just going to call devoxx.sharedInstance. Load schedules for conference. The identifier is DV15. And the callback will give me a list of dictionaries. I call schedules. And then I can just log that. So I can just say for schedule in schedules, print schedule title, because I know they have a title field. And it's optional. Because, of course, a map, when you call a key on a map, the key might not be there, in which case the result of this call is optional. And yeah, I think it's okay. So we should be able to run it.
Suspense.
Suspense. Nice spinner again, and boom. So if we look at the console, here we have a list.
Wow.
With all the days.
Magic.
Magic. So pretty simple. Once again, the big advantage here is I didn't have to set up any special connection with my phone. I can use just the emulators. There's no phone connected. My phone is here. It's not not even plugged. Anyway, and yeah, and I can do that transparently with the NSURL session. So I think, yeah, this is done. Let me go back to the slides. So are you impressed or not?
Yeah, yeah.
I mean, it's not like I showed you that yesterday evening.
But it's really verbose, Swift.
Yeah, it's a little verbose, and the Swift language may take some time to get used to, especially with the optionals. But in the end, it's really powerful because it makes your code much safer. So yeah, I showed you all that. This code. Okay, and the step 3.
I'm still confused with the exclamation mark, optional, not optional. It's quite...
Yeah, it looks like you're asking questions and giving orders. It's really boring. Anyway, so next step.
Okay, next step. So we have fetched the schedules. It's displayed on the console. Nice, but it's not really useful for our application. So we need the schedules on the watch. And this step is going to display the schedules in the list view. So the script is the following. The phone will send the schedules to the watch by using another API, the data API. We'll see why. The watch will receive the schedules and will display it on the list view, a specific list view that is designed for the watch, a wearable list view. So the first thing is to understand what is the data API comparing to the message API. So the data API, so an API providing by Google Play Services, support the two kinds of communication, one-way and two-way communication. You can interact with your remote node. You can, of course, send something that is bigger than your 100 kilobyte payload. You can send your Titanic movie if you want. But what is really interesting, you remember that the message API will send a message to a connected node. With the data API, you can send a message, and if your remote node is not connected, and then it becomes connected, it will receive the message after that, because the data API will cache the information for you. So it's a nice feature. So when the connection is established, it will receive the information. And an important part, of the data API is the notion of data caching. We will use the data caching, and we will use the benefits and some questions that I had by using it. So this picture described what we will use. So the goal is to send our message through the data layer, but here our message is not a simple data item with a path and a message payload, a byte array. It will use a data map, something a hash map with a key and a value, and here you will be able to push a string, a long, integer value, whatever you want. And the different methods that you see there, put data map request and put data request, etc., will be used, in fact, to encapsulate your data map in something that will be used
across the wire.
Yeah, exactly. It will implement the notion of parcelable object, but all the boilerplate that we use to create a parcelable object are
taken care of.
Taking care about the put data map request.
Okay.
And on the watch side, the message will be received, will be parsed, etc., and you will be ready to browse your data map. So here, quickly on the watch, we will send a message to the phone. So it's the same thing. We already implement this feature on the step 3. And on the mobile phone, when we want to send the schedules to the watch, we will see on the code that we are going to prepare our message, we are going to get the schedules, and to create an array of data map where we will store the day and the text that is provided by the schedules. When we are ready to put our data item on the data layer. On the watch, we will implement a listener that will allow us to use a method. Where is it? It's on data change. The on data changed will be used on the watch to say, hey guys, you have received a new data, you are ready to process it. And when the data will be retrieved, will be parsed, we will send this data to a wearable list view adapter. The wearable list view adapter will provide the data to our wearable list view component.
Maybe you can show directly in the code.
Yeah, so we can switch to the code. So this is the step 4. We have here the watch, the phone, you can see here we just changed the send schedules. So when we receive the schedules from the server, we call the send schedules method, And the send schedules method will prepare our data map request with the same schedule path that it will be used by Android Wear to identify your data items. And there we will browse our schedules and to create our map. And then we'll be ready to put our data map array list prefixed by list. That's it. Then our map is ready to be put on the data layer. The phone here, the watch, implements a listener, a data API data listener, and this listener will provide us the on data changed. So what means the on data change? It means that when you put a message on the data layer through the data API, you are able to say to your remote nodes, hey guys, this data item has been changed. This means that if you put a data item that didn't change, you will not fire this on data changed. So the on data change receives your buffer and is ready to parse it. And then, so here, it checks that what we received is a list of schedules. Here we use a wrapper. So the wrapper is quite simple there. What it does, it will parse your data item and then it will create your list of schedules there. And you see that here we are looking for the /list key. We receive our object there, our array list, and you are ready to send it to our list view adapter and to say to our adapter, we have received a new list of schedules. Please refresh your adapter, refresh the view, and you are ready to display it. Of course, here we have attached our activity to the list view adapter, and the list view adapter that is defined there, it uses a specific method that is called settings item view. So the list view adapter is a container that will contain a set of rows. And here we will attach to the row a kind of animation.
And now you're bragging about animation, okay?
Sorry?
Now you're bragging because you put some animation in your...
Yeah, because I'm really proud of it.
It's fancy that day.
So this class implements the wearable list view on center proximity listener, and when the item is in a center position, we will change the scale of this row. We will increase it or decrease it. So, ready for the demo?
Once again, all that are APIs that come from the Android normal SDK.
Everything is provided by Android Wear. So we are going to deploy our APK to the mobile. So as you can see here, when you develop with Android Wear, through Android Studio, you have to deploy the APK to the phone and the APK to the watch. When you release an application, we'll see this later, you will deploy only, you will release only one APK, the APK of the mobile, that will contain the APK of the watch. I don't know how it works in
Yeah, the packaging works the same. The watch app is bundled into the phone app.
Yeah.
And then when you install the app on the phone, it detects that there is a watch app and it sends it to the watch. Okay. So it installs it on the watch. If you have enabled auto installation, otherwise you have to do it yourself. But
okay, so I deploy on the phone. So I'm ready to deploy on the where.
And now, because you're using the data API, the app on the phone doesn't need to run when the watch calls it. It can be woken up in the background.
Exactly.
So that's the advantage of using one API over the other.
Here the watch part. And that's it. We have Monday. Look at the animation. It's really important. Tuesday.
Whoa.
Wednesday. Thursday. Friday. Big applause, guys. Yeah.
Okay, you know what? I'm so impressed.
Show me how you done.
I have to say, I'm so impressed that I have to cool down a little bit, because otherwise I won't be able to do any demo. And by the way, it's halftime already. So we're going to do a 10-minute break now. You can come back at 11:10, and then I'll show you what I got in my store for the iOS part.
Okay, see you guys.
And now we're going back to the demo. So yeah, I was kind of amazed by what Said showed us with the nice animation and so on.
Yeah.
But let's switch to my screen, and I'll show you what I got. So yeah, we just model some classes to store the data. This is pretty standard. We'll just lay out the components on the storyboard to show the list of schedules, and use the interface controllers to configure and react to all that. Let's go back to the demo. So I'm still using the very same project. Here I'm just going to remove this from the extension delegate lifecycle, because we're not going to use it anymore. We're just going to display the list when the screen appears and not when the app is launched. So let's get rid of that. That's the first step. Second step, let's create a class to actually store the data so that I can show you what DTO looks like. It's really easy. I'm just create a WatchKit class, call it schedule, to store our object, so that's easier to play with. And it will just have two fields, a string and an href. They're both optional strings, because it might be that they are not there in the dictionary, and yeah, that we don't initialize them from the get-go. I just create a custom constructor to initialize the object from a dictionary. Okay, and this will just let title equals. Yeah, so in Swift, methods and constructors can have parameters with an internal and external name. So here I'm just going to define dictionary as the internal name. So when I call the method, I'll call it init from dictionary. When I use the variable inside the method, I'm going to call it dictionary. It's just a small trick. Everything is done to make the code as expressive as possible. Dictionary title. I know it's supposed to be a string. And if I don't get it, then print. Once again, we're supposed to do better than that in terms of we can throw exceptions and so on, but I won't go into that for now. Cannot find title, return nil. And I'll do the same for the href. Dictionary href. Okay, print. Cannot find href. Return. So now, beyond those two guards, I know that I have a non-null title and non-null href. So self title equals title self dot href equals href. That's good practice to just validate the inputs. Well, actually, now that I'm seeing it, I could probably remove those question marks, and it won't complain. Yes, it does, because oh yeah, I need to call the super constructor first. And that should do it. No? Why? Okay, anyway, let's put back the question marks. That's the tricky part with Swift. Sometimes it's the warnings change from one version to another and you lose your track. Anyway, the last thing we're going to do, that's just for logging purposes, but we're overriding the description. It's like basically overriding the toString method in Java. So var description string, and this one will return self.title, and since it's optional, I unwrap it, which is dangerous because then if it's null, I'm screwed, but hey. So this is a simple data transfer object, and it will contain the data coming from the JSON. Now that I have that, let's go to the Devoxx singleton. To the Devoxx singleton, and we will just replace. So the callback, instead of taking an index dictionary, an array of index dictionary, it will take an array of schedule instead, which will be more, easier to play with. And here I have an array of dictionary. So instead of going through, sending the schedules array directly, I will just do var schedules equals. So that's how you initialize an array in Swift with this special syntax. And here I will just go for schedule in schedules array. Okay, schedules that append. I'm just using my constructor from dictionary schedule. The auto-completion in Xcode is kind of annoying sometimes. It suggests things that are completely irrelevant, but okay. So yeah, that's all there is to it. And now I can load this method and get a list of schedules back, and all the parsing and the mapping is handled for me. So that's a good thing. Before we can actually display this data, we need to do some layouts. So I go back to my storyboard, get rid of this label that I don't need anymore, and instead I'm going to put a table. For those of you who are used to doing some iOS development, it's nothing to do with a UI table view controller. It doesn't work the same way, even though it displays similar data, and you're going to see how it's different. So here I just added a row in my table. I will add a label as well that will be used to display the title. And I'll just lay it out so that vertically it's centered in the row. And there's a small special trick that you will see. It's very intuitive, but if the title in the label is too long, then it needs to go over several lines, which I specify by saying that this label has 0 lines. I mean, of course.
It's logical, yeah.
Very logical. Yeah. And if I forget to do that, then it will remove the end, and yeah. So this is what we need to do. The important thing here is that if you look at the inspector here, at the tree of components, there is an interface controller, that's the screen of the watch. And inside it there is a table, and there are rows, and each row will have a table row controller. That will be another class. And this will be used to manipulate the internal components of each row. So what I need to do if I want to use that, and you'll see why later, to this row controller I just need to give it an identifier. And in here I'm just going to call it schedule. That's it. Okay. Now that I have done that, I will create a class to control this row. And this will be a simple NS object, no need to extend any special UI class. And I'll just call it schedule row controller, NS object in Swift. Okay, and this one will just have no, I'll do that afterwards because it's much more impressive. So if I go back now to the storyboard, I can link this schedule row controller with the proper class. Okay, so I'm mapping a visual component with its controller class.
Okay.
And now that I've done that, I can click this special button in the upper right corner here, this cryptic icon here. If I do that, it will open an assistant editor that automatically displays the relevant class beyond. So if here I select the row controller, it should display the scheduled row controller, but it does not. Okay, so shit happens. Let's go back to the manual way. Extension, schedule row controller. There we go. So now we have the visual part and the code part that are side by side. And normally, if I control click from the inspector to the class, it should suggest something, but it does not. It doesn't work.
Oh, yeah.
Anyway, I think it doesn't have time to see. It needs to load the storyboard again or something to update the links. Anyway, we'll just do it manually. IB outlet, so I'm creating an outlet var title label, and it's going to be a wiki interface label. And actually, it's a weak var, special kind of var that can be thrown away when we don't need it anymore. Now, if I save, I get a special icon in the sidebar that I can send to my row controller. I mean, come on. It's not even working that way. So far, the demo went fine, and now it's all screwed up again. What's happening? Schedule row controller. Anyway, I will show it to you in the... I will cheat a little bit, move forward. Apple Watch. No, that's not. Step 4. Okay, so if I go back to the storyboard and I go to the schedule row controller, okay, it still doesn't show, but I have my connection done. Yeah, so now if I go over this icon, I can see that it has linked the visual component with the class that's behind it.
So it seems that Xcode, the last version, is not quite
well,
stable.
It's always been like that. There are some glitches here and there. Sometimes you need to do special voodoo tricks like basically shutting down Xcode and rebooting it.
Is it Xcode or the Apple Watch part of?
No, it's just Xcode. It can happen also in iPhone development as well.
Okay.
There are some small glitches like that. But anyway, once you've done that, now we have the schedule row controller, and we have a label in it. And also, if I go to the interface controller and go back to the automatic mode, okay, I also have an outlet in the interface controller to access the table itself. And this will allow me to do the real display of the data. So now that all the connections are made, I can go back to interface controller itself. I will call the load schedules method from the will activate so that every time the screen appears on, the view appears on screen, we load the data again, we refresh it. So we're just calling shared instance load schedules for conference, and we receive a list of schedules. So the first step, and that's where it completely differs from what you might be used to if you know UI table view controller. The first step is to configure the number of rows of the table by calling set number of rows. By the way, a table in the Apple Watch can have several types of rows, in which case you need to call another method. But here, all the rows will have the same type. And this is where I use the identifier that I defined for the row controller earlier. Then I use the enumerate method to go over all the index schedule parts of the array of schedules. So this shows you also that in Swift we have the notion of tuples, and this is a tuple. And I know you're impressed by tuples, right?
Yeah, exactly.
That's not worth an animation. But okay, anyway. And once I have that, I need to retrieve the schedule row controller, and I use the row controller at index method on the table. I downcast it as a schedule row controller. And if I can't find it, it means I made an error in my data, in my table configuration. So I can just return and do nothing or process the error properly. But when I'm done, I can just set the title label text to my schedule.title. And that's it. Now, if I just run on the emulator, the operation couldn't be completed, of course, without any message or whatever. So here, normally when I do a clean build, it works. There we go. Launching the app and shutting down the emulator. Let's do it again. So it's nice because it also shows you that sometimes the tools are a little brittle, especially when this is really related to the Apple Watch emulator. There are some small bugs here and there left in the production version, but hopefully it will improve with time. And this time it's actually doing nothing, so that's a good opportunity to see this absolutely amazing spinner. Isn't it nice? I mean, come on. That's Apple design, guys. Let's do it again.
Is it a native spinner?
This one, yes. The one that appears when you launch an app is native. The interesting thing is that, yay!
Oh.
And now we can see the schedules.
Bravo.
You're impressed, right? And you see I have some animations as well. When I click on it, it goes dark and so on. Right?
The Apple Touch. Huh?
The Apple Touch, exactly. So that's it. We've shown you how to display a list of items on the watch.
Okay.
How cool is that?
Yeah.
Once again, creating the schedule. Okay, this is all what you've seen. And we can switch directly to step 5.
Step 5, yeah. So now we have the list of schedules. That's okay. But the goal is to, when you will tap on a schedule, is to open the list of talks, the list of sessions that are attached to the schedules. And for that, we need to work on the click listener of the wearable list view. So for that, each time that you will tap on the schedule, we will retrieve the schedule object that is set on the tag. The click listener will be called, and we will attach the listener, retrieve the schedule's data from the tag, and then we'll be ready to display the selected item. I'm not going to show you that because it's quite simple. I'm just focused on the main part of the application. So here on the on-bind view holder, each time that a schedule is processed by the wearable list view adapter, we will store the schedule object on a tag, and this information will be used on the on-click method. On this method, we will retrieve this schedule, and I think that the goal here is just to use a toast message on the screen.
To show that the item has been clicked.
I'm not going to run the app, guys. Believe me, it's working.
Okay. This is really simple indeed. In the case of the Apple Watch app, we're just adding a title to the screen. So if you remember, you have the list of schedules, and there is no title to this controller. So we'll just do that so that we can see the change.
Okay.
And yeah, we're going to create a new screen just for the schedule interface controller.
What is the segue? Or?
Yeah, so in the concept of segues in Apple, I mean in iOS development, it works for iPhone and the watch. It's transitions between screens.
Yeah.
So it just says when you click that button, you trigger that segue and it goes to this other screen. Mm-hmm. And segues can have associated data and stuff like that. So
because
here,
everything is driven by your
storyboard.
Storyboard, yeah.
Indeed. So this is the storyboard now. We're just creating a new screen, and the arrow that you can see between those two screens is actually the segue. Mm-hmm. And we just give it a name. So we select the segue and we give it an identifier. In this case, is show schedule in the upper right part. Okay. And once that is done, yeah, by the way, the segue here is linked to the row of to the table. So that means that automatically when you select a row in the table, you trigger the show schedule segue. And the only thing I need here is I have a special method in interface controller, in WK interface controller that I have to override. It's called context for segue with identifier. So of course, if I had several segues coming out of my screen, then I would have to basically switch on the segue identifier to make sure that I'm using the right one. Here I only have one, so I don't need to use the segue identifier. And all I need to do, I receive a row index. That's the row of the index of the row that's tapped, and I can just go to return the row index yen elements, of the schedules array that I've loaded earlier. Okay, and this is all I need to basically extract the schedule I'm interested in and send it to the next screen. And in the next screen, I can catch this context with the method of awake with context. So I receive a context that is any kind of object. I can check that it's really a schedule, and I can assign it to my schedule. So that's how you communicate data from one screen, one interface controller to the next. No need for click listeners or anything like that. And then when the screen appears on, when the view appears on screen, so when the will activate method is called, I just get my schedule back. I have to check it's there because it's optional, and I set the title of my of the view controller itself, and that's it. That's all there is to it. So it's really simple. We didn't want to go too much into details about that because there's a big demo afterwards. So that was for step 5.
Okay. So next step, we have the schedules. We have to display the slot that are attached to the schedule. And the first question is, are we doing to get back on the network again and again and again? And I will say no.
So yeah, we are on a watch. It has very limited capabilities in terms of network connectivity, in terms of processing power and so on. So it's a bad idea to go to network every time we display the screen.
Exactly. So in Android Wear, we are going to use the data caching feature provided by the Data API. So you remember this picture with the set of methods that we have to call to prepare our data item and to send the data through the data layer. And here, the Data API will help us to cache this information on the different devices. So when we want to get the data from the cache, the process is quite simple. Your application has to first to check if the data exists on your local cache, and if it's the case, it will just reuse this data. If not, he will ask the phone, "Hey guys, give me the data, the torch session or whatever." So first step, we will build a URI that will be used to identify your data item in the cache, for example, /schedules or /talk or whatever, or /speaker with an identifier. And then, if it's found, it will send this data item to your process to parse your data and to send your data to your views, your wearable list views or whatever, your custom layout. If not, as usual, we will send a message API, a send message to the remote device. And if we send the message to the remote device, the data will be retrieved and stored in the local cache. So here, what we will see on the phone part, on the send schedules, this is a little trick that we use to force the onDataChanged method to be called on the remote device. Is to say that every time we use the Data API, we will change the content of the data API, for example, by putting a timestamp. Each time you build a data item, you put a timestamp, and the remote device will say, hey, the data item has changed, so I have to call on data change. Here, it's not required because we will use the local cache, so we can remove this line. On the phone part, we will call, of course, the get schedules, and the get schedules, we have created a method that is called get schedules. We will provide the data path that we need to retrieve from the cache. We will build a URI, it's quite difficult to say it. And then we will fetch the local cache. It's the step 1. Step 2, if the data item is not found on the local cache, what we will do is just to send the message again to the remote device. If it's found, so it's the normal process, the normal path. We get it, we parse it, and we ask the list view adapter, hey, this is the data that you are required. So the step 1, 3, and 4 will be used without requesting a call to the remote server. And it's quite a useful feature. So the step 6, we are going to build it, and then maybe to review some part of the code. So here I build the application for the mobile device. So I can review here some part. Yeah. Here on the watch, you will see that we have created a new activity. This is the slot activity. This activity will be used to display all the sessions related to the schedule that you have selected. And the slot activity is linked to a layout, this one. Slot activity. And if I review the slot for the square form factor, if you have this kind of error on Android Studio, don't be scared. You just have to change the version of your API. It means that, let me just deploy the application. It means here that by default, Android Studio takes the last version of the API that have been installed on your computer, but my application doesn't support the API version 23. It is Marshmallow, so I have to downgrade this 22, and it's working. Okay, the application has been deployed on the phone. Then I deploy it on the watch. So here, you know, guys, it's the same principle. I have created an activity to manage the sessions. I have created layouts, customs layout, and here the slots will be stored in the variable list view. Same principle as the schedules. And there, I don't know what it's doing. Okay, I choose my emulator. Yes. It's deploying the APK. Yes. So here I have my list of schedules, and I will select, for example, Monday, and this is my list of talk related to Monday.
And it was already in the cache because it loaded very
Yeah,
fast.
exactly.
So this has two advantages. Not only will it load faster, also it avoids going back to the network and having to parse JSON and so on, because everything is stored as objects in the cache.
Exactly. When the data is going to fetch from the remote server, you will see a progress bar. So I checked the Tuesday session. You see, it's really beautiful. We have this animation, and we have colors. You see? Oh,
it's
yeah.
Amazing.
Okay, Wednesday, cool.
And you see, it works the same for all the days.
For all the days, yes, it's same principle. But anyway, you see here's the Glanceable part. We have one information saying that for Wednesday there is opening keynote, room 5, from 9:30 to 11:30, in one glance. It's really important. So you see, one wearable list view, on click listener. I get here the talks from the phone or from my local cache. It's available from my local cache. I can display them.
And the local cache, in the case here, is what? Is a database? It's a file?
It's something.
Okay.
I think that the Data API is using an SQLite database that is installed on each node, but to be honest with you, I don't know.
It's like black box.
It's like, yeah, it seems like a black box, yeah.
Okay. Well, that's refreshing, because in my case, it's going to be a little harder than that. But okay, let's switch back to my screen. So this is what we've just done on Android. Let me show you how this works with the iPhone version, I mean the Apple Watch version. In my case, actually, since the talks, the list of talks is a little more complex, and you can have break slots and talk slots and so on, I didn't want to go that far, and you'll see why, because there's a data model to design. And so instead, I chose to to show the caching mechanism on the schedules itself, but the principle remains the same for the slots. Yeah, the first thing I'm going to do, so we talked about animations earlier. Here, I'm going to go to the network, to the cache, to do a lot of background things. And if I leave the application like that, if you remember correctly, the last time I launched it, the screen is black, and boom, data appears. We don't know if something is happening in the background. So the first thing we're going to do, actually, is to create an activity indicator. By the way, little thing to know, in Apple Watch, there is no component for displaying an activity indicator yet. This little spinner that you saw earlier is the one in the OS, but you don't have access to it so far. So we have to be a little creative. And the way you do animations in Apple Watch for now is by using animated images. Sorry. So if you go to this special project on GitHub, for example, some guy actually had fun reproducing the spinner on the on the Apple Watch by creating all the intermediate images. So it's 30 images that are cycled through like that anyway. So
is it open source?
Yeah, it's fully open source, and you actually you can customize it, but the default images are there for you to pick up. So the way we do that, I'm just going to show you real quick. Go back to the demo for that. So in the interface storyboard, in the table here, where is my palette? There it is. I'm just going to add an image above the table, give it a width relative to container 1, so that means it takes 100% of the width of the container, and I'll do the same for the height relative to container 1. So now it pushes the table back down, and I have the whole screen to display something. And in that case, actually I'm going to switch to another project so that I can show you the images when they are done. Step 6, start. So here's the same project, but at a different stage. And if I go to the assets of my WatchKit app, I have an activity directory with all the images corresponding to the individual steps. So now, if I go back here in my table, I need to add, sorry, again, that's not what I wanted to do. Where is my palette? There it goes. I need to add my image above the table, give it relative to container for both width and height, and the image, just to show you what it looks like and to do the layout, I'm going to choose the first one. By default, it scales. I want actually center, and boom. So that's the first image of the spinner sequence, and then I need to do something to activate it. In order to be able to control the animating image, I go to the interface controller, select the image, and I do an outlet. Yeah, I do an outlet like that, and this time it works. Yay! So that's the activity indicator. So that's the kind of low-level things that we hope that we won't have to do anymore in the future. But okay, it didn't take. Let's try again. Activity indicator. No, not yet. Come on. Ah, okay, was in the wrong one. Anyway, so now I have my image, and before I call the network, I can actually say, well, first let's initialize the image correctly. Activity indicator, set image, UI image, image named. No. Just a sec, let me check my notes, making sure I'm not doing something stupid. Yeah, I was doing something stupid. So set image named, yeah, and call it activity. So then it knows that it's going to be an animation, and for each step in the animation, it will just append the number of the step. Let me show you the code in full screen. It would be easier to read. Okay. Now that I have done that, before calling the network, I just do self activity indicator, start animating. Actually, I should probably display it first because it's going to be hidden by default. Set hidden false. And then when the result is coming back and I'm finished with the rendering, I can just do stop animating and self activity indicator set hidden true. So that's just a little trick to show you how you do. You can do this sort of things. It's a little tinkered, but yeah, hopefully they will add a proper component in this palette so that we don't have to do that anymore. I'm just going to run it while I'm switching to the other thing. Okay, so now it shows. This is the default spinner from the system, and then it will display my screen, and it will crash. So I start again. This is really... Okay, and now this is my spinner, and it gives some much more feedback. Anyway, so now that we have that, we can do plenty of things in the background and make sure that the user is waiting because he knows there's something happening. In terms of caching, we want to do the same thing as on Android Wear. We don't want to go to the network every time. I mean, at least we want to show some data while we are going back to the network if we need to refresh the data. And there are plenty of things that we can do in terms of caching with CloudKit and all that. I haven't gone in that direction yet. I just wanted to show you a very amazing thing that you can do, actually. You can have a database in your watch. Really.
Oracle or?
No, no Oracle. It takes too long to install. It's an SQLite database, but you can actually have a database, and instead of accessing it directly, you can go through an ORM. It's not Hibernate, but it's pretty close. It's called core data. So by the way, if I want to be able to use core data, first off, I need to import the framework. So I go to smartwatch, build phases, link binary with libraries, and here I call the core data framework. Actually, wait a second, I'm not sure this is going to work. I need to do it on the watch extension itself. Build phases, link binary, okay. Core data, there we go. So there's a core data framework for watchOS 2 and there's one for the iOS. It's not the same, but it works the same. Now that I have that, so we have linked with the core data framework, what we need to do is to create an object model. So like any ORM, core data needs some mapping strategy to know how to map SQLite records onto objects. And to do that, we do it visually because, hey, it's Apple. So in the WatchKit extension, we're going to create a new core data model. And we call it smartwatch. And there is a visual editor for it. So here we can model all our entities, the attributes of entities, the relationship between entities. By the way, there's a table mode and there's a visual mode. Okay, it's not available if there are no entity. Okay, so be it. So yeah, now I have the model. I will come back to it later. The first thing I need to do is to create the code that will actually access the cache, so database cache. So new file. And this time, I'm going to create an NSObject subclass called Devoxx cache. So I will have one class to access the network and the other one to manage the cache. Separation of concerns. Okay. And that's it. So here, actually, I won't do the live coding for this part because it's really boring. So I'm going to cheat a little bit and go to the end project. Show you what it will look like and explain the different parts. So Devoxx cache, there we go. There are plenty of moving parts in core data because it can be very sophisticated. You can use an XML file to store your data instead of an SQL database. You can do pretty neat things with REST APIs and so on, but we won't go into that. So here what I'm doing is first I'm retrieving the document directory, so that's the directory where I'll be able to store my database. I'm also retrieving my object model. That's the model that I've just created. Okay, this visual model will be stored, serialized as XML, and I'm loading it. The persistent store coordinator is actually the part that makes the link with the SQLite database. So I just create a URL for it. You can see the name of the database here. And it's stored in the application documents directory, which is not always easy to find, especially on the emulator, because you have UUIDs in there. So that's why I added this print URL part, which can be useful to debug and actually see the data stored in the database later. And the last parts I need to do, and that's really the tricky part with core data, I need to create object contexts. So object contexts are pretty much like the templates in our Hibernate, for example. It's what you actually call methods on to do some fetching, to create the objects, to link your objects with the data storage. And here I'm creating two of them, one that I call the main object context, and the other one is the private object context. The reason why I'm doing that is that core data is not thread safe. So I cannot use objects from one thread into another one, and especially I cannot use objects created in the background thread in the foreground thread. So if I want to display objects in the user interface, that is the foreground thread, I need to fetch them from the foreground thread, and I cannot use the background one anyway. So that's kind of the tricky part. If you don't do that, you're going to get plenty of exceptions that are really, really hard to debug. It's pretty much like the lazy initialization exceptions in Hibernate, you know, the kind of things that drive you crazy. Well, here is the same thing. It's just a matter of doing the things in the right place. So I'm initializing the private context with the main object context as a parent. This will allow them to use both the same object model. And then I have a special method to save the context and save the parent context at the same time. Now that I have those two contexts, the principle is very simple. When I read data, I read it from the main context. When I write data, I do it in the background context. And if I keep that discipline, everything will be fine. So if I go back now to the interface controller, just to show you what it looks like. So I have my activity indicator that I just shown. And now I'm still calling the same load schedules for the conference method that is in the Devoxx singleton, but the implementation of that is a little different. Instead of calling the network directly, the API directly, what it does is it goes to the cache. So it has a Devoxx cache instance as a member variable. And it goes to the cache and sees, okay, do I have some schedules in the cache? If I do, then please display them directly. You don't need to wait. We do that on the main thread, because otherwise we will have some refresh bugs and so on. That's just a small trick. But we call the callback immediately. Now, the data, even though we have some data in the cache, it might have changed since the last time we went to the network. So we still want to go to the network anyway, but this happens in the background, so it doesn't block the user interface or anything. Now we're calling the API, like before, okay? Initializing the URL, creating a data task, and processing the return. But when we process the return, before we return it, and we call the callback method with it, we have to store it in the cache. So that the next time we come back, we have some data. And this is done with just the self-cache save schedules from data. Okay? So all the serializing, the interpretation, the mapping from the objects that the data that I get from the network into objects from the core data part, this is all done in the cache. Okay? So nothing really fancy here. The real magic happens in the cache, of course. So if I go first to the getSchedules method here, what this does is it calls a private method to get the schedules from a special context. Okay? And in this case, it uses the main object context, because once again, when I'm reading, I do it from the main one. And this one just takes the context and perform block and wait. This is the part that makes sure that all the operations on the context are called on the right thread, and we don't get any exceptions. So I'm just preparing a fetch request. I want objects of the conference type first. So the idea here is I load there's a conference object at the root. Let me show you the object model now. So this is what the object model looks like. Okay, so it has two entities, a conference entity and a schedule entity. Conference has even code label localization. Those are all strings. Schedule has href and title, all strings. And the special part is I have a one-to-many relationship between conference and schedule. So conference can have many schedules. And schedule has one conference here. Okay? So this means that I can load the conference. And once I have the conference, I can access the schedules property, and I have all the list of schedules for this conference. Let me go back to Devoxx cache. So here, what I want is to fetch an entity of the type conference with an even code that I already know. Okay, DB15, and I'm just executing the fetch request. Once again, this fetch request can fail with an exception, so I need to try and catch it. If I have some results, then I retrieve the results as conferences. Okay. By the way, those are NSManage objects classes. So once I have created the object model here, I can create Swift classes that represent each of these entities. And I can generate those directly from here, create NSManage object subclass, and it will generate the code for me. Really easy. Now, some people prefer to write it manually because why do it simple when you can do it complicated? And here in the model group, I have a schedule extension. So the way it does here is that when it generates the subclasses, it does it in a way so that you can regenerate the model without losing your customization. So if you want to add some methods to your data objects or whatever, you can, and don't be afraid because it won't override them. So here is the code that's generated, and this one is going to be overwritten every time I generate the entities. And this one is where I put my custom functionality. Okay, and one is the extension of the other. So that uses a special extension feature in the API, in the SDK. So now that I have that, let's go back here. So I'm retrieving conferences from the context, and there's the first result normally, if it's there, because there's at least one element. I can retrieve a scheduled set. By the way, if we go back here, the schedules of a conference is an NS ordered set, so that means that the order is important. It loads them from Monday to Friday, so I should be able to display them from Monday to Friday. And the way I model that is if I go here in the inspector, I can check the ordered checkbox right here. Devoxx cache, coming back, and we just load the schedules from the conference. And if we don't have any, then we retrieve we return an empty array of schedules. If we have them, then we just do that, and we return the schedules. Okay? Here we're just reading from the cache. The counterpart, of course, is being able to write to the cache. So once again, I have this public method that calls a private method to which I want to do that in the private context. So once again, I call the method on the context to be sure I don't get any exception. I get the data, I parse it. Pretty much there's no big difference compared to what we did earlier, except that this time I don't have a special constructor, because I just wanted to show you that you can also create objects like that. And so here what I'm doing is that I want to update the model. I don't want to rewrite it every time. So I have a lot of get or create methods to just, okay, if it's already in the cache, then I'm going to use it. If it's not, then create it. Pretty standard mechanism. So getting or create the conference itself. Then I'm loading the schedules array. And the interesting part is here. So get or create schedule for href. This part will, again, on the context, try to retrieve the schedules with the href that I pass. If it's there, then I just return it. Okay, that's the part. If it's not there, then I have to create it. And that's how you create an object in the core data context. You insert new object for entity name in the context. While I have the href, I can already assign it. I save the context so that I fetch everything to the database, and I'm done. And then I can return this. So if I go back to the calling method, now here I have a valid schedule wherever it came from. I can assign all the fields. By the way, I'm doing the href again, but it doesn't matter. I'm assigning all the fields, and once again saving the context. I just assign the schedules to the conference, and that's it. And now I can call, this method doesn't return anything, it doesn't call any callback, it just saves to the cache. Okay? Once this is done, once the context is saved, all the data is in the database. So I can show you now. Let me check first. What I'm going to do here is I will uninstall the app so that it clears the cache and the database does not exist. Okay, let me go back to proper scale here. Otherwise we won't see anything. Okay, 75% was nice. Okay, so that's the phone. I uninstalled the app from the phone, and at the same time it uninstalled the app from the watch emulator. So if I go to the launch screen, the app doesn't appear anymore. Okay. Now that I have done that, I think I can just run it. Okay, I have another, yeah, sorry, I had another debugger running in the background. Okay, and now I have a big bug in the Xcode, completely forgot to show me what I need, anyway. Okay, so it's launching the app, displaying the screen, and the first time it goes to the network, it parses everything, it stores in the cache, takes a lot of time, okay? Now, if I just click an individual talk, of course, in the real code, it shows the list of slots for the schedule, but here it just shows Monday in the title to show you that it's showing some data, and if I go back, displays instantaneous, okay? And it's shown, it goes back to the network. When it comes back from the network, it stores in the cache and refreshes the user interface again. So it's much faster, and it takes into account the fact that we are on the watch and we don't want to wait anymore. Okay?
Okay.
So this is not as easy as the data API on the Android Wear, but it's actually, I mean, it's clearer what we are doing, and we know where the data is. By the way, you can see on the console here, I have the URL of the database. So just to show you that it really worked, I can open my Finder, access this path, and here I have a smartwatch.sqlite database. And because I have an SQLite browser, I can just launch it and browse the data. And here I can see I have the conference in the conference table, and I have a list of schedules in the database. So this is where the data is stored.
Okay.
And of course, all this is linked to the app. So when I install the app, the cache disappears automatically, and I don't have to care about it anymore. And it doesn't take any room on the watch after the fact.
Yes, because on Android Wear, the most confusing part is the management of this cache, because it's managed by Google Play services. And sometimes it's quite difficult to understand how to clear the cache, because you cannot manage this by your own. And you will try to uninstall your application, but the problem is that your application will be uninstalled on all your nodes. If you clear the Google Play Services cache, the problem is that your phone will lose all the watch is connected to your phone, so you will have to perform a factory reset on your watches, so it's quite complicated. By the way, the first version of smartwatch for Android Wear, we're using an SQLite database on my phone. So.
And you accessed it directly without any ORM layer in between.
Yeah, exactly.
So it's also possible to have a database on an Android Wear watch. Should stop bragging about that.
Okay, so I would say it's not the last part, but it's an important part. We have seen how to display the schedules. We have seen how to link one activity to another with the on-click listener. So we tap on a schedule, we retrieve the schedule object, and then I can show you this after. We are just going to call another activity, the talk activity. And when you will tap on a talk, the next part will be to show this talk activity. So the talk activity is in fact an activity that will display a grid view pager. And the grid view pager is just a set of pages that you can organize by row or by column. So it's a feature that is providing by the UI UX design guidelines.
And the goal of this feature is so that you leave plenty of greasy marks on your watch, right?
Yeah.
By doing this
exactly,
and that and this and that.
They can be used by the CSI to get your fingerprints.
To get your fingerprints, yeah.
So each page will be attached to a fragment. So in Android, you have an activity. An activity can be linked to a layout. But if you want to see multiple views attached to an activity, you will have to use fragment. You can have one or several fragments attached to one single activity. So here, we will use a fragment grid view page, adapter. And this class will be used to attach each page to a specific fragment. For example, at the top left, you will, upon your wrist, it's a talk fragment, the summary fragment, and the speaker fragments. So we will have one fragment for the speaker, and if we have several speakers, we will create several fragments. And the navigation will be from the talk info to the talk summary, and if you swipe up, you will get the first speaker and then the second speaker. This is what we are going to implement. So here, the steps are create an activity, design the layout. The layout will contain a grid view, a cart, and a custom layout. We will create a grid view page adapter to provide the data to the different fragments. We'll create the fragment. This is our classes. And we will use an event bus. We will see how and why. We will retrieve the talks and the speakers that are linked to the session, to the talk session. And of course, we will reuse what we have learned with the data API. This means that we will retrieve the talks and speakers from the phone, and then this data will be stored on the local cache. Each time the watch has to send a request to the phone, such as give me the speaker or show me the Twitter profile of the speaker, a request will be sent to the phone by using the message API, of course. And we have a bonus on this application that you do not implement on your Apple Watch.
Stop bragging, please.
Application is that you will be able to see the Twitter profile of a speaker on your phone. It's quite simple to do that, but it was used to implement, to illustrate the confirmation activity. Confirmation activity is an activity provided by Android Wear, and you can display some kind of animation that are provided to you. So here, the grid view pager has 2 rows and several columns. Row 1, column 1, talk information. Column 2, summary. On the row 2, we will have speaker 1, speaker 2, speaker N. So we said that the talk activity will be linked to talk fragment. And when we define the grid view pager, we have to create the layout, create a fragment. It's obvious. The talk activity here defined a specific view. This is the grid view pager. This is required to have your rows and columns, and some dots page indicators that will be displayed at the location that you will decide, on top, on bottom, etc. I prefer to put it on top because on the Moto 360, you have this flat tire design that is a little bit annoying. So our custom layout will look like this. The title, the room, the day, and the schedule. And on the round watch, you will see that the design is also suitable for this kind of form factor. For the talk fragment, same principle. We use the watch view stub that will allow us to have a distinct layout depending the form factor that we will use. Here it's for the rect, and here it's for the round. And here we are using a box inset layout. The box inset layout will allow you to set your elements in a square box. This will allow you to see all the information even in a round form factor.
Once again, you have to do plenty of special things to
support
those
it's quite challenging sometimes. Summary card. So here we are using a card element, and this card element, you can scroll the information with it. This means that the card element is enclosed in the card scroll view element. The card scroll view will manage all the stuff all the things that you are going to do with your watch. But we have added an additional feature that will allow you to expand or collapse the summary. Why we did that? Because to ease the navigation between cards. Because if the summary is too long, you will have to browse all the summary before reaching the speaker part. So the layout for the summary part is using a card scroll view that is provided by the wearable library. Oops, I don't know what it is. Yes. And here, when we type of the summary, the expand will be performed, the expand or the collapse. The trick is quite simple. We use the abbreviate method coming from the common utils library with a size that we put. And each time we expand or collapse the summary, we force the card to switch, to move to the first position. But here, we have to communicate between the talk activity and the different fragments. To do that, we are using an event bus. It's an open source project called Busware that is inspired from another project, open source project, event bus. And Busware allows you to send events locally or remotely. It means that if you do not want to use the data API, you can use an alternative such as Busware. It's possible. But for my application, I have used data API and the Busware, the event bus, only for local message exchange. So I use the method postlocal to broadcast my events between all the elements. To install event bus, it's quite simple. You declare a dependency on your Gradle file, and to post an event to your different element, activity and fragments, you use postlocal. To receive your event, you have to declare a method on event with the class that will be used to. It means that the match will be performed between the event you send and the class that you are processing. In order to receive the event, you have to register to your event bus. And the confirmation animation, we have just put an action behind a button. And when we type on this button, we will display the animation provided by Android Wear. The confirmation activity is something that is provided, that you can use it. You just have to declare this activity on your manifest file to say, hey guys, I want to use the confirmation activity feature from Android Wear. And when you type on this Twitter icon button, we do two things. The first thing is to show the animation. The second thing that we do is to post a message that will be catched by the talk activity. And the event will be to say, hey guys, send a request to the phone and send the following Twitter profile name, and please display the Twitter with for the related Twitter profile. The animation is just to define a kind of animation type. You have the succeeded animation profile, it's just a V. You have open on iPhone, and you have also, I have a problem, or the information is not available on the network. You have 3 or 4 kinds of animation. From the phone, when you receive the follow on Twitter, for example, so here, what we do, we retrieve the Twitter name, and we will just start an intent. We declare an intent, and we will say to Android, please fetch and open something related to twitter.com/Twitter name. If the application is not installed on your phone, Android will open a browser, open the page, etc. If your application, Twitter application, is installed on your phone, you will see the application.
Okay, all this to show that apps on watches can really be sophisticated. Here we have an event bus, we have databases, we have network access. You can do a lot of things. And then it's just a matter of selecting which ones are relevant on this kind of platform.
Yeah.
Okay. So we'll go quickly over some equivalents for the iOS, because we won't have time to cover everything today. But by the way, of course, you will have the slides, and the code will be open sourced on GitHub, I think. So
we just have to discuss about that, because
we're still disagreeing anyway.
Yeah.
So yeah, I'm just going to time travel real fast on the equivalent. So here on the Apple Watch, we don't have this concept of cards and so on that you can switch. You can just display lists, and that's cool. So it's really easy that way. We have added the feature to both apps to manage favorites. The way we do it is that we do it using the cache. So we just store this an ID and the flag, it's true or false if it's a favorite or not, in a local database, and then we can retrieve your favorite talks. In the case of the Android Wear, we even store that to the calendar, so we can integrate with the calendar so that you can receive reminders and so on. You can see that in the code later. Anyway, we can retrieve favorites from the calendar at Calendar Helper. We'll go very quick over all that. And yeah, the communication once again goes through the phone using the Google Play services. Reminders come from the calendar. You can use the alarm service. Okay, we go real fast about that. You need to ask for special permissions. And yeah, that's it. And you can see the events on the calendar. We'll go over the demo. On the iOS, it's the same. We just store the information in the database. The special thing here, I don't know if I can show that to you now. The special thing here, if I can show you here. So if I launch the app, okay, where is it? There it is. So if I launch the app and I access special talk, for example, this one, okay, from the talk, I can just push real hard on the screen, use the force touch mechanism to add to favorites or remove from favorites if it's already in there. And then it changes the little star. So this is the kind of thing that's really easy to do in iOS, and uses, I mean, it's part of the holistic approach. We use all the user input at our disposal.
And it's a good use case of the force touch.
Yeah. So force touch basically means context menu for everything. And when we want to, so when we add to favorites, we have to schedule a notification so that 10 minutes before the talk, we receive a notification on the watch, and this is done through the phone. That's the funny part yet. On the Apple Watch, there is no way to schedule a notification from the watch itself. You have to go through the phone. And for that, we use the watch connectivity, which is pretty much equivalent of the equivalent of the data API that we saw on Android Wear, to send a message to the phone schedules a notification, and then we receive the notification on the watch. So that's the watch connectivity framework. I won't show you the code here, and that's the step 8. Of course, we can build some custom notifications on both platforms. You can customize the layout and the display of notifications when you receive them. By default, of course, on both platforms, when you receive a notification, even if you don't have a custom notification, it will show. But you can customize it, add some more information, add some special actions associated with your notifications. And that's the same on both platforms, actually. I won't go into details about that. Yeah. It works the same on iOS. And yeah, I can really lay out my custom notification controller that way. Small bonus, on the Apple Watch, you have something special. That's the glance. So I can show you here. Sorry, I forgot to launch the. OK, I can show you here. If I'm on the home screen, on the main watch face, I can just slide up. And there I have my glances. It's actually a list of pages where I have some more information. It's not very clear, but anyway. And here I have my special glance for Devoxx that shows me the next stock in my favorites. So
it's a nice feature.
Yeah.
But complication is complicated to understand complication.
Yeah.
Why complication?
The same thing, but I think they felt smart when they found this name, but everybody like, what? Okay, and of course you can customize your glance controller, how it's displayed, how it's laid out, and so on. The code is really simple. The only thing is a glance cannot be, you can have no user interface, there cannot be any button or anything, it's just a display. And yeah, you can update the glance data every time it's displayed, anyway. And the last step is to release the app.
Yeah.
I think it's pretty standard on both platforms.
Yeah, except that when you release an Android Wear application, you have to
check the box.
Check the box, and
if you forget, then
you don't have to miss it because it's not clear on the page.
So once again, all this is in the process of the Google Play Store for Android Wear, and for you need to include permissions and package names, versions, that kind of stuff. Generate the signed APK, send it to Apple,
and this is what we do when you bundle your APK. You just have to bundle and to submit the phone part, because the mobile the watch part is already inside it.
So don't forget to check the box.
Yeah, Android Wear.
And then you're good to go, and it goes through the Play Store. On iOS, well, it's pretty simple. It's the same thing as on iPhone. You package the Apple Watch app with the iPhone app, and you release the iPhone app like any other, and the app is built on the inside, and then you wait for Apple to review the app, and you wait again, and you wait some more. It takes about a week. It's killing us. Like the app was released yesterday for the Apple Watch, and I sent it to Apple 8 days ago. So
it took me a couple of hours to review.
So that's also an important difference. Anyway, just a word about Pebble. If you want to see Pebble watches, I have plenty of them here. But the reason why we didn't cover it is I already wrote a couple of Pebble applications, and it's really a pain. It's C, the language is C, or JavaScript. You can use JavaScript, but it's more limited. And the C API is just rubbish. It's really low level. You have to manage memory. You have to create structures and so on. It's amazingly complicated. You can either use a text editor, or they have something called Cloud Pebble, with which you can write apps in the cloud. And it supports both iOS and Android, so it's kind of interesting that way. And it has some SDKs also to embed some components, I mean, to make it easier to make an iPhone app that talks to a Pebble app, for example. And there are several devices, a Pebble Classic, Pebble Time Round. Now they have a round form factor as well. And everything is distributed via the Pebble app. I won't show you the detailed code, but that's just the code to call the network.
No live coding?
No live coding, no. And that's just the code to parse the response.
Oh my God.
Not display it, nothing. So it's really, really hard. So in summary, as hopefully you've seen, there are some huge inequalities in terms of development, ease of use on both platforms. My argument to that is that obviously Apple took some time to refine and finish both the tools and the APIs. That's why it took them a year and a half more to release the SDK. But in the end, it shows. And yeah, it's true that the learning curve is shorter on Android Wear because you're still using Java, and a lot of the components are common between the Android phone and the Android Wear. On iOS, it's a little more complicated because you have to learn Swift, and because very few people know Swift already, and yeah, you have to use some special tools. Clearly, the tooling support is not up to date on Android. All the custom components, like the Wear list views and so on, are not supported in the Visual Designer, and they are in Xcode, so that's a good part for Apple. And for both platforms, the documentation is really not finished yet. There is a lot of ground to cover and things to explain in more details. An important part, when you're thinking of making an app for a watch, don't forget that not all apps make sense on smartwatches. It's not a small phone. So apps that typically work well on smartwatches are countdowns and timers. So that's a countdown. Everything that looks like a status check. So what's the temperature right now? By the way, it's 14 degrees outside. What's my next session? What's the score of the game? Whatever. Everything related to remote control. So I wrote a Pebble app, for example, to control my shutters, my electric shutters at home. Works very well. Every kind of notification responder. So I receive a meeting. What's the meeting about? And standard stuff. And all the data trackers. And this includes all the health data trackers. So the Fitbits kind of things.
No support.
There are plenty of apps that don't make sense. Games, forget about games. It doesn't work on watches. Any kind of long reading, so news, books, forget about it. Of course, buying from a watch is not an ideal experience.
Yeah.
Titanic, no.
Forget it.
And anything that requires text input basically is not really adapted to that platform.
One more thing.
Of course.
Of course. So, Sebastien, I think about it, and I think that we have a gift for our attendees. Smartwatch will be available on GitHub.
So the entire code of the application, not just what we have shown, but really the working application as it's released on the app stores.
It will be available in black.
So for Android Wear
and also white.
Okay, so we will send you the links. Actually, if you go to smartvox.com, we'll put you the link for the GitHub repositories there. You can download it and customize it and play with it however you want. And that's it.
That's it. So we can see that time is up.
So sorry, no time for questions, I guess, but thank you.
Thank you very much.
Awesome.